So there's a homework for 2.5. It's set to be due on Monday. We left off with a definition for the slope of a tangent line. We actually had two definitions, and I'm just going to leave or get back into where we left off at with an example. Okay. Let's see.
Hello, Cassie.
Hello.
DNS working up again?
I couldn't hear you.
The internet's malfunctioning again?
It's going okay. I mean, they haven't renewed the hotspot, so I hope we don't disconnect, but I can still record and then like post the lecture later.
Yeah. Wait, are in like certain classroom or are you at home?
Oh, I'm at home.
Oh, okay.
Okay, trying to find where we left off at. Okay, 1 second. We did this part, we got a slope, we did this part together, we found an equation, okay, I think we're here. I think I'm missing a page, so just a moment. I'm just going to go ahead and put up the definition we left off at, and then we'll get to an example. Okay, actually, we'll put both of them on the board. The first definition we talked about was the slope of the tangent line being the limit as x goes to a of f of x minus f of a over x minus a.
This is an example?
No, I'm just putting the two definitions up from last class before we do an example. Okay. Second definition we left off with is the limit as h goes to 0. And again, this is your slope of your tangent line. Of f of a plus h subtract f of a divide everything by h. Okay, we're going to let f of x be x squared minus 3x plus 5. Okay. Finds the slope of the tangent line at 2, 3. Okay, so I'm going to practice using the second definition. We take the limit as h goes to 0. And for f of a plus h, we're using 2 for a. It's f of 2 plus h. And f of 2 divided by h. Unfortunately, these are the kind of examples that would really benefit from a full whiteboard, but we'll try to make it work. So for the next step, I'm going to go here and all the way across the board.
Are we gonna do anything with the 3?
No. We're putting in 2 plus h. Everything's over h. All right, so we're going to have a 2 plus h squared minus 3 times 2 plus h, add 5. Okay, minus f of 2. So you're putting in 2 for your function. We're going to have a 2 squared. Minus 3 times 2. Plus 5. All right, so I'm going to just expand everything, have numbers cancel, and then simplify what's left over. So the limit as h goes to 0 of, so we've got 4 plus 4h plus h squared. Subtract 6 and this minus 3h. Okay, there's a plus 5 and then minus 4. Plus 6 and then subtract 5. Okay, looking at all of those numbers, there's a 4 minus 6 and a +5 and a -4. Wait, hang on. There's a +4 and a -4. There's a +5 and a -5. And then there's a -6 and a +6. Okay, cool. So there's 4h here. And then subtract 3h over there. To get positive h. And then plus h squared. Okay, we'll go ahead and factor out an h. It's not a big deal, but still. Okay, this the limit as h goes to 0 of 1 plus h. Which would be 1. Okay, another example.
Wait, where did you get the 1 from?
Oh, you let h go to 0.
Oh, okay. Wait. Okay. Okay.
Okay, let f of x be the square root of 2x minus 3. We're going to find the slope of the tangent line, which we're calling m, at some general point, at some point a, f of a. This is the first part of this example, part A.
Wait, for this example, we're gonna like separate them in letters, right? Like,
Yeah, there's going to be a part B.
or is this? Oh, okay.
And we're using the second definition where we let h go to 0. So the limit is h goes to 0. Okay, we're using f of a plus h minus f of a divided by h. All right, is the limit as h goes to 0.
Hey, actually, Cassie.
Yep.
For the last question, for like for the last example, find the m at 2, 2 and 3. So we don't do anything with 3 at all, right?
You could use that to
Like we
find
do
the
nothing with
equation
3.
of the tangent line, but for finding the slope of the tangent line, you don't need the value of 3. But you can use it if you want to find the equation of
Okay.
that line. Okay, so we're
Okay,
going
that's one no. So
to move
yeah, I
on
get it,
to
I get
this
it.
example, but we can talk about that one like in office hour. All right, for this, we're going to put in a plus h right here. And then subtract 3. And then subtract the root of 2a minus 3. Okay, divided by h. Okay, we're going to need to multiply by the conjugate of the numerator, which is going to be the root of 2 times a plus h minus 3 plus the root of 2a minus 3. Okay, so just keep that first root how it is. And I'm changing this sign here to a plus. And then copy that root of 2a minus 3. And then divide by the same thing. Okay. So when I take these numerators and then FOIL them, that first root multiplied with the other root, the roots undo each other, and what's left is 2 times a plus h minus 3. Okay, then you're going to have this root times that one, and then a negative of the same thing, that root times that one. They're going to cancel out. You can work it out on scratch paper. But then what's left is the negative of these last two terms multiplied together, which is a negative of 2a minus 3. Okay, I'm just going to kind of work out this numerator. We've got a 2a, and then a plus 2h, and minus 3, and then minus 2a, and then plus 3. So the minus 3 and plus 3 is gone. There's a minus 2a and a plus 2a. So what's left is 2h. Okay, and then h over h is 1. So we're taking the limit as h goes to 0 of 2, which is 2. Oh, I lost this piece here. We need to copy all of that down. So we're not going to get 2. Let's go back. I mean, the numerator is correct. It's just more going on in the denominator. Okay. So there's my h right there, but I need all of this next to it or multiplied with it. So times the root of 2 times a plus h minus 3. And then plus that root of 2a minus 3. Okay, so there's a 2h over h times all of that. There, and there. Okay. Actually, to save some writing, I'm gonna say like those h's reduce, they're gonna reduce to 1. Cross them out. Okay, we're gonna let h go to 0 once those other ones have like canceled out. So this is an h going to 0, and I think that's it. So got is 2 over. As this goes to 0, we have a root of 2 times a minus 3 plus another root of 2 times a minus 3. So there's 2 of them. 2 of the root of 2a.
Wait, that's a plus sign, right? The bottom one?
Yeah, plus.
Okay.
Okay, and then those 2's are going to reduce. So the slope is 1 over the root of 2a minus 3. Okay, for part B, we will find the equation of the tangent line at x equals 2.
Wait, by the way, how did it end up with square root of 2a minus 3?
Through some scratch work right here. So these h's reduce. So there's a 2 over.
Yeah. Oh, I think I see. You get rid of the h and then you did the math in the bottom by replacing h with 0. Okay, I think I see it. Yeah. Thank you. It just at the order of how you do it kind of confused us. Apologies.
I don't have a lot of room on the whiteboard, so you'll have to use your own scratch paper sometimes because I can't fully write out what we need to do. Okay, so the equation of the tangent line, you're going to need your slope, you're going to need your input, which we have 2, and then your output, f of 2. So let's get f of 2 first. Okay, so if you look back at your function, it is the root of 2a minus 3. So it's the root of 2 times 2 minus 3. A root of 4 minus 3 is a root 1, which is 1. Okay, so we've got an input, got an output. We need the slope when a is 2. So this is a 1 over the root of 1, which is 1. Okay, we put this all into an equation for a line. There's different equations to use. I used the one where we have y minus y1 equal to m times x minus x1. Okay, this slope here is 1. And then y minus y1, where y1 is your output at that point for, yeah, we're going to put in 1. And then times x minus 2. Okay, y minus 1 equal to x minus 2. Add 1 to both sides, you've got y equal to x minus 1. Okay, so the derivative of a function at a point is the slope of the tangent line to that function at that point. So we've been looking at derivatives so far, and now we're just going to introduce some notation. Okay, so the derivative of a function f at x equals a is written as f prime of x and it describes the slope of the tangent line at x equals a. Okay, so we can go back to those two definitions I put up at the beginning and replace m with f prime. So f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h, or there's that other one. We're going to write f prime of a is the limit as x goes to a of f of x minus f of a over x minus a. Okay, so first one. So you can read it as f prime of a, or it's the derivative of f when x equals a, and it's the limit as h goes to 0. Of f of a plus h. Subtract to f of a. Divide by h. Or there's a second option. You can do f prime of a. Or it's the derivative of f when x equals a. And it could be the limit as x goes to a. Of f of x minus f of a divided by x minus a. Okay, so those are our derivatives. And we're going to bring back something we talked about earlier this semester, which is average velocity. Okay, average velocity was change in position, then divide by change in time. Okay, we're going to have a function called s, And S of t, t for time, is, well, we're going to write it down. So let S of t be a position function. Okay, cool. So we're going to also have H be elapsed time. Okay, before we talk about average velocity, we'll draw a small picture. So for inputting values called t, or that's a variable for inputs, t values. We're going to have a time for t at a. And then we're going to have some positive elapsed time, h, and go over to a plus h. And have h get smaller and smaller, and have a plus h go towards a. So our average velocity. Okay, for your change in position, those are the outputs you get from putting a through that function s, so s of a. And we're going to look at s of a plus h, and then find the change of position. So we're going to take s of a plus h, and then subtract s of a. Okay, divide by change in time. So we're going to take a plus h and then subtract a. Okay, with that positive a and that negative a, what's left in the denominator is h. To get to the instantaneous velocity when t equals a, we let h go to 0. So we take the limit as h goes to 0. Of the average velocity of s of a plus h minus s of a over h. Which would be s prime of a So the derivative of that function s when, in this case, t is equal to a. Okay, and I've got one example for you. So we're going to let an object's position be given by the function s of t equal to negative 16 t squared. Add 10t and then add 400. And then those outputs are units of feet. Okay, we want to find the velocity, or it just says we're going to do what is the velocity of the object at t equals 2. Okay, and it's 2 seconds. So we're going to find s prime of 2. Okay, s prime of 2. Ooh, this is going to be messy. Let's put it basics in. We're putting in an s of 2 plus h. And it's the limit as h goes to 0. Subtract s of 2. Divide by h. Okay, it's going to fill up the whole board, probably, but we're going to have the limit as h goes to 0. There's my h. In the numerator, we need s of 2 plus h. So we're putting 2 plus h through this function with negative 16 times 2 plus h squared. Okay. Add 10 times 2 plus h. add 400. Subtract S of 2. So I'm going to subtract and then put all of that in here. Put 2 through the function to get negative 16 times 2 squared. And 10 times 2. Okay. And then plus 400. Okay, I'm going to try to finish this example and then we'll go. I know that this is technically the end of class, but I just want to get to the end of this problem and we'll call it. Okay.
So we're done.
Nope. I'm going to finish this problem and then we're done. So after expanding the numerator, which you can do on scratch paper, I got a numerator of negative 54h. Minus 16h squared. Over h. Okay, then reduce that to the limit as h goes to 0 of negative 54. Minus 16h. All right, then let h go to 0, which makes this go to 0. And I got negative 54, and it's feet per second. Okay, and that's it. So I just suggest that you try expanding this whole numerator and check that you got the same results as I did. And I'll see you tomorrow in class. Thank you, everybody. We're done.